We'll now pass on to the second keynote lecture in the session, technical session. And once again, Professor Shin doesn't need any introduction because he has been with us for the last 3-4 years. Everybody in India knows. I don't want to impinge on his time available. So I would like to invite Shin. Professor Shin, are you there?
Yeah, I'm here.
Okay, the floor is yours. I'm trying to save time. You are well known in India, so I don't want to introduce you. We're looking forward to your lecture.
Yeah.
You can start.
Yeah. Just wait. Okay. Thank you, Professor Madhav, for your kind introduction. This is my third time participation to the symposium, and first one is the last Saturday, and the other one yesterday, and today is the main event. Okay. The topic of my presentation today: applicability of recycled soil mixed with the bentonite and the polymer as a waste landfill liner. I think it's the same similar concept as Professor Charles, talk about the recycling of the concrete. But here, after process of all the concrete demolished, and finally we can get the recycled soil. So I think this is we need in Korea and the other country. And I'll introduce about the sanitary landfill site in the metropolitan landfill site in Korea. I think Professor Madhav, visited this site. And secondly, I'll talk about the development of amended compacted clay liner by utilizing the recycled soil. And I'll go talk about more detail about laboratory test and the result and the quality of amended compacted clay liner, and the conclusions will be drawn. So this is, I think, all the days view of the Seoul Metropolitan Landfill site. I think it's a Nanji landfill site. This is all the garbage, mountain. So that I think that's 1970s and 80s or something, So this is after completed this landfill site. This is we say Nanji-do municipal solid waste landfill site. Only this garbage from the Seoul, 1978 to 1993. This is Han River there. I used to work for this highway construction work as a civil engineer, 1983. So I know all this garbage site was, a very severe odor, and also a lot of fryers, and also garbage, and many people coming there to collect the recyclable, material for their, use. And the large area, 2.72 cubic million square meter, and the waste volume 9.972. So about the height 95 meter. I think so. This most of garbage, that like charcoal ash, we had a lot, and also plastic vinyl bag, those things a lot. But as you see here, the river is here. Now this is a kind of alluvial, the sand around here. So that's why during the time of the landfill, and we found that a lot of that contaminated water leachate and migrate to the seas, the river side, Han River side. So we had to construct it like a vertical cut-off wall. I think half of this by sheet pile, and another half is by the deep mixing method, So about 6 kilometer long, vertical cut-off wall. And we have here the monitoring, I think a leachate collection, well 31, and we also has a methane gas collection pipe per minute about 167 cubic meter and the 106 collection holes here. And nowadays this area using as a golf course and or another one is in Sky Park. I think this is a World Cup soccer place here. And this is Doom, and this is so heating, the power plant and so on. So now this is completed, 1993. Now they need, another landfill. So they moved to the western part of Incheon. So that we called, so maybe I call here Seoul Metropolitan Landfill Site, but this is a Metropolitan Landfill Site. We collected, past 28 years from the Incheon, 19% or, MSW, and from Seoul, 48%, 33%, surrounding metropolitan area we called Gyeonggi province. So the area divided by site 1, 2, 3, 4, and so far up to is completed, and section site 3 is under now landfilling. So we need, because this is a reclaimed land, so we need a large volume of the cover material. So that here, so this is a view from the sky to the site, and this is site 1. Now we are using this site, this completed, and now using the golf course and the 36 holes here. And the second one just completed. And now number site 3-1 section, that's now under landfilling. And the other one is now preparing, and next future, landfill site here. All these areas is reclaimed from the sea. As you see here, this golf course in the left-hand side, we collected all the gas, and we generated 50 megawatt, power generation here. So I think successfully we maintain. I think a previous landfill site is not the sanitary landfill. This is, like uncontrolled landfill, but this is a well-controlled. We collected all the gas and leachate, and we treated, as a good manner. This is the second one, and just completed. And number 3-1, this is now, landfilling. This completed the bottom liner system, and we filling the garbage here. And one of my former students works for this the landfill site since 2018. So we want to use. So we developed amended compacted clay liner. So will be used for cover soil system in this particular site. So the Metropolitan Landfill Corporation, so they request our group to develop that, kind of complementary alternative, compacted clay liner. This is a schematic diagram of the bottom liner system, and also the slope system for this Metropolitan Landfill site. This is a little bit different. And you see here, let's say this is garbage on the top, and the 30 centimeter of the leachate collection and removal system. And we have a 1,000 gram per square meter, pretty thick, just non-urban geotextile. After then, we have a high density polyethylene, HDPE, 2 millimeter. After that, we have a 50 centimeter compacted clay liner. This is a regular system, but we here, as I said, it's reclaimed from the sea, and we have a clay layer, and water table a little bit high. So we want to drain the water. Any water comes into this site and we want to drain the water. So we have a discharge layer about 30 centimeter across the stone. And above that, we want to have a stabilized, it's a good bearing capacity. We have some chemical treated, the clay layer about 20 centimeters. This is, maybe we can cement mix, the clay layer and have a good, the bearing capacity. And also the slope system, we have original soil and the non-oven geotextile 1,000 gram per meter square. Tell them bentonite instead of because this is slope, maybe the thicker the soil layer, clay layer, maybe sliding, failure. So we have a bentonite and then HDP 2 millimeter and the geocomposite. After then, see, this is like a geocell layer. Normally we covered it, maybe like here, maybe we normally fix it against the wind blow of this system. We put in the waste tire, but the waste tire has a problem in the trunk. Then maybe water accumulate inside, and that no water is not seeping out. So drain out. So that's why they give extra load and drag the slope surface. That cause of the failure of the slope. So we alternatively we use that geocell, which Korea developed it, and also I helped in for developing this geocell. And I think there is a connection. This is a problem that they're solving, and we fill the recycled aggregate. So then permeability is very good, and also can certain combine pressure against the slope, and this is successfully now we are using in the field. I think this is I obtained the Professor Manoj Datta. He presented in the Cochin 2011 for this landfill system. I think from different our landfill system, and here you have about drainage layer on the top, but here, let's say, here you have a thicker, we have a 50 centimeter, but you have a 90 centimeter, and but your membrane we have a 2 millimeter, but you have a 1.5 millimeter, and so this is a typical 1999, the Korean EPA designated, that standard. Bottom system, bottom liner system, municipal MSW, and then leachate collection and removal system, the 30 centimeter thicker, and the non-oven geotextile, and then HDPE, compacted clay liner 50 centimeter. If you don't have any HDPE, we use a 1 meter thicker compacted clay liner and the original, ground. I think this is a view of the completed bottom liner system and the side, the good sanitary landfill system. This is a leachate collection, the drainage system, and this is a cover system. This is also you can use HDPE, and Professor Charles say maybe he can eliminate HDPE. That's a good idea. I think we learned something from Charles, and last time we use his the knowledge and the technology for using the plant here, the steep slope, to increase the shearing strength of the cover system, and we adopted some kind of wire mesh in between on the cover system, and we the sprayed of the seed spray on the top and about 10 centimeter thick, so they can increase the stability even in steeper slope. I think that works even in South Korea. Here we have some the alternatively you can use HDPE 1.5 millimeter with 30 centimeter compacted clay liner, or without HDPE, we can use 35 centimeter of the CCL here. And we have all others, like we can use drainage layer, geocomposite, or recycled stone about 30 centimeter, and then compacted clay liner and gas collection layer. We can use sand or recycled stone and 30 centimeter thick. So all we maybe we don't need to use the HDPE, and I think at the Seoul Metropolitan Landfill site we don't use HDPE there. I know, as far as I know, in Japan they have LDPE, little bit flexible geomembrane in the cover system, because of a lot of settlement occurring, because decompose of the garbage MSW. So that's why they accommodate that. So here, but we use geocomposite here, the possible. So this is a view of the cover system. One is Oriental Chemical Industry, the factory they have. We placed here as a lime waste sludge, and this is the populate water pipe for removal of rainwater in the cover system. I think this is a geocomposite. It's a very easy to installation and have a good quality control, instead of bring the crushed stone and the compacted or so on. And cost-wise, maybe this is maybe cheaper nowadays. So we prefer to use this in the landfill system. So now we are going to the main event about my research work, development of a amended compacted clay liner by utilizing the recycled soil. So the annual construction waste in Korea, about 64.3 million tons, because of we had the 1988 as a Summer Olympic Games. During that, before and after, we had a lot of the renovation of the apartment, old apartment and the new apartment, a lot of highway construction work and the tunnel construction work. And also a lot of redevelopment of urban area. So we created a lot of construction waste in South Korea. And all about the recycling aggregate, we sorting all that finally, fine sand and also the fine aggregate, and we recycle it. But the waste concrete about this, and the asphalt about this, and the recyclable soil, 2.8%. So the recycled portion about 85.1%. Normally we use this sand, residual material for the giving the fertilizer with the mixing with the this material, and giving the fertilizer and the distributing the golf course, So also like we have snow, and we can have the sodium, the chloride and the salt, with the mix with the sand, and we spread it and demelted about, melted about snow, ice area in the winter time, like this. So use of cycling soil, about 50% of that for embankment soil, and the other one for backfilling soil in the retaining structure. So, but problem is metropolitan landfill site. We have a lot of landfill site either in the reclaimed land from the sea, the west coast area, and or is a mountain area. So we don't have any enough clay layer, clay soil for covering and the liner material. So this is the we obtained the recycled soil from the construction waste material. I think this is a all process of the somewhere is a larger aggregate, and here some metal detection, and also some non that combustible the garbage, and also here is a combustible garbage. Somewhere we have residual soil that normally these people they dump near to their factory complex, and then that contaminated or recycled soil that, you know, goes heavy in the mountain, like, you know, 3 million cubic meter like this, you know, so abandon it. So we want to use that, those soil as a, you know, the compacted clay liner. As you see that, so what you can do, we can mix recycled soil mix with the bentonite. That would be, you know, good, but the bentonite, you know, that sometimes is expensive, you know. So we want to reduce the amount of bentonite with the adopting small portion of the polymer powder here. As you know, the bentonite is very much, you know, expand about swelling 10 to 15 times of original volume, and 5 times observing the water of its own weight. And because this is, you know, that NH2O, you know, so van der Waals force, and this build weaker, you know, bonding, you know, power. So that's why the water filtrate, and also that swelling very much. And we collected that recycled soil from the construction waste, you know, production company, and we have 1, 2, 3, 4, 5 specimens, and these are the criteria for recycling for these. And all this, I think particularly we are interested in this part, and here this part, see passing 0.075 millimeter, and CBR, I think, are pretty good here, much better than, you know, criteria 10. And also the plastic index, I think, is none. And here the organic content, I think, is important, is less than 1. So let's say grain size distribution over here, more likely polygraded sand, okay? So by the USCS also. So we preparation for the permeability test using the mold diameter with a 15 centimeter height, you know, 10 centimeter. We compacted the soil. We do the moisture content, optimum moisture content plus 2%, which gives the lowest the coefficient of permeability. And we have here, but bottom mesh, and we porous stone, and we compacted the clay inside, and also top porous stone, and rubber ring, and we sample and do variable, you know, the permeability test. And we have a soil specimen, and this is a test program for this soil. This is a weathered granite, you know, soil, and the recycled soil and the clay. Actually, we did with the clay with the bentonite, you know, a long time ago. But about 3% of the bentonite with the mixed clay, which gives, you know, permeability, you know, 1 times 10 to the minus 7 centimeter. But here, our focus here, the research work on the how to use the recycled soil, you know, soil, clay, bentonite, we have a 2, 3, 4%, and recycled soil, we have a 4, 5, 6, 7% by the weight. And here we have a program. So we fixed from this program the bentonite percentage, 4%, and we fixed the 4, and then we changed the, you know, polymer powder, the mixing ratio, the 6.616 to the 0.28, and also we adopted, you know, polymer 1 and the polymer powder 2 also. We want to see, you know, it's a phenomenon, and this is a result of the permeability test with the bentonite, with the recycled soil. Let's see, this is, I think, about this percentage, was 7.5% of bentonite, which it gives the 1 times 10 to the minus 7 centimeter per sec for the coefficient permeability, maybe, but 7.5 is a very high amount of the bentonite. I know bentonite we are importing from Gujarat or somewhere in the India. And so we adopted, you know, that the bentonite mixing ratio 4% from previous, you know, experimental work, and we adopted that the polymer, okay, polymer powder, and you see the polymer powder. I think it's this not 7 point, actually 4% times bentonite percentage, the weight of bentonite times 7%. That means 0.28%, which maybe gives, this is not satisfying, 1 times 10 to the minus 7. So that maybe this about this range, maybe they satisfy this sample. So we get this sample. Now we make the soil specimen with the mixing of the recycled soil mixed with the bentonite and also polymer powder, and we made 100 samples with here 0 curing days, 7, 14, 21, 28 days. So make a diameter 5 centimeter, height 10 centimeter specimen. We conducted the unconfined compressible strength test with the curing days. As you see here, with this is, I think, is a bentonite and the recycled soil as 0, and that's about the standard of about 500 kPa. That's a requirement for that bearing capacity for the compacted clay liner. But this is just sorry, that recycled soil does not satisfy. But you see here 4% of mixing ratio. And if you mix more bentonite and unconfined compressible strength is decreasing. So I think we decide to adopt 4% for this, and all this satisfies the more than higher than the 500 kPa. And now we adopted polymer powder. As you see, the 4 times 4 multiply 4%, so 0.16%, so that, but this is a non-mixed. Now we mixed with the 4%, but with increasing the increase up to 6%, but 6% gives a higher value, and this is a little bit low value. And the 7% polymer, I think that's slippery, and some the problem and the weakening of the specimen. And also we conducted the shrinkage test for this final specimen, and this sampling plate with the soil sample height about 2.3 centimeter and the diameter 11 centimeter. We follow the ASTM for shrinkage test with the 40 degree Celsius and duration of the this. Yes.
Sorry to interrupt you. You got another 10 minutes time, Professor.
Sure. So specimen is the 4 centimeter. We want to measure the that distance of the this point, and see that amended compacted clay liner specimen. Let's see the shrinkage layer, and the recycled soil is the shrinkage layer is very higher, and also with the bentonite 4% also very higher. But this is a weathered granite soil. Maybe we use this as a compacted liner, but this is expensive. This is mountain soil mostly. I think it's not available very much. So when you mix with the polymer here, polymer 1, this is very much reduced. See this. So this is very good. We sometimes maybe we are preventing the cracking. About compacted clay liner, and with polymer liner too is much better situation. But this is it's not available. Maybe we just sampling for this to see, just check. And so this is a swelling test with bentonite and also with the recycled soil bentonite and together, and the bentonite material, and this we use 2 different size of the graduate cylinder. This is like much bigger swelling, but actually that all total volume this is much higher because of this smaller. The cylinder has a more contact surface, which induce the less swelling problem. And let's see the result of this. I think just pure bentonite about 283% of the swelling, but the recycled soil with the bentonite is not much. But with the inclusion of the polymer powder, increase the swelling, free swelling problem. So that will help when the cracking some surface of the compacted clay liner. This may be function of the sealing. I think the healing of the cracking. So I think it's a good result. And the quality of amended compacted clay liner. So design criteria of compacted clay liner in Korea, the coefficient of permeability 1 times 10 to the minus 7 centimeter per sec. And also unconfined compressive strength in the 500 kPa. So there's no the requirement of the PI value and so on, So I think if we satisfy these two the components, then we can use this. So as from our test result, unconfined compressive strength of RSBT with the bentonite specimen increase with the bentonite mixing up to 4%, but then with the increasing more volume of the bentonite, 8%, at the curing day 28 days they decrease. I think that more mixing with the softening the soil specimen. And with the polymer layer, the RSBT 4%, about 4, 5, 6, 7% increase, but the final, the 7% polymer, decrease a little bit about unconfined compressible strength. As you see here, this is a recycled soil, and now we have a polymer 4%, 5%, 6%. This 7%. So we adopted all that unconfined compressible strength, higher than 500 kPa, which the criteria Korean EPA, give. So concluding remark, based on the laboratory soil test results, amended compacted clay liner is proposed with utilizing the recycled soil and the bentonite and the polymer powder. Because nowadays we have a lot of industrial waste landfill in the West Coast, and we had a couple of consultancy work to the assessment of the slope stability problem, because that landfill the area you digging out, that slope may be sliding. So how we reinforce it by maybe jet grouting more or so on. And also we want to maybe expand the existing, the landfill site to the laterally. Then we digging out for the bottom system. Then the slope maybe could failure. Anyway, so recycled soil with the bentonite 4%, and the polymer, I think that's 4% specimen that meets the requirement of the Korean EPA permeability, 1 times 10 to the minus 7 centimeter per second, and also the unconfined compressible strength, the 500 kPa. And the addition of a polymer to RSBP4 is significantly reduced shrinkage rate and the higher swelling potential due to absorption of water efficiently. And with increasing the polymer mixing ratio for RSBT4 specimen, the USC increment rate is higher than the reduction rate of water content. And so this is also important for this, because the people, they're aware of the, some groundwater pollution. So we all the time we got to do when you're developing, new grouting material or something. So water quality through the soil column test. So we have a column test. We put in we developed, compacted clay liner, and we got water get through, and we collected the water from the bottom and check the degree of water pollution, which is far below the soil pollution category 2. That means about the factory complex, parking lot, or playground. Not residential area is the #1 category. So that meets the requirement by the EPA criteria. So the proposed amended compacted clay liner, BSBT4P7, from this study can be used in the municipal solid waste landfill and also the industrial solid waste landfill. I think this is all my presentation. It's a beautiful view. Last year, October, we had a board meeting in South Africa, and I took a photograph from the west coast of Cape Town. Thank you very much for your pay attention.